Okay, college algebra, unit 7. This is the next to the last unit. So everything we're doing in this unit, we just finished doing. The unit circle in degrees, there's one big thing that we're doing here is instead of measuring in degrees, we're going to measure in something called radians. So it's the same concept, but just a different measure. So think about it this, when you have degrees, you know that a complete circle is 360 degrees, okay? There's nothing magical about that. Someone, when they decided 360 degrees was the circle, they could have decided 100 degrees or 200 degrees. There's nothing magical about that 360. The nice thing about 360, it's a number that divides by a lot of numbers, so that's what makes it real convenient. It divides by every number under 10 except for 7 evenly. So it's a very nice number for dividing by 4 and by 5 and by 3, something like that. There's another unit, and we're not going to test over this, but called graduals. So they divide the circle into 400 pieces. So a complete revolution would be 400 times. Okay. So what we're doing here, we're shifting gears, and we're dealing with something called radians. Okay. So it's just another way of measuring a complete revolution around a circle. Now, if you are on your calculator, I'll bring that up in just a moment, but if you're in your calculator and you plan on using your TI Inspire, it is your responsibility and no one else's to make sure that you are in radians versus degrees if you want to find something out in terms of radians, okay? So I'm waiting for that to join, but we'll come back to that in just a moment. So here's what you will need to know. So a complete revolution around the circle is 2 pi radians. Okay, so 2 pi radians takes me all the way around the circle. So if I start here at 0, so if I start at 0 and I go all the way around the circle, so if I go all the way around the circle, then I find myself back at 2 pi radians, okay? So keep in mind, in the last unit, we would have called that 360 degrees. But we're going to leave degrees off, and everything is going to be radians from now on. So if I go all the way around the circle, counterclockwise, that is 2 pi radians. So what would it mean instead of, if I didn't go all the way around, if I went halfway around? So what if I went from here? So if the complete revolution is 2 pi, what do you think half a revolution is? And hopefully you're screaming out that that is pi radians, okay? So what you need to get acclimated, what you used to think of as 180 degrees, we're now considering that is pi radians. So in terms of pi radians, okay. Now, what would it mean? So if you start at 0, instead of going to pi, what if I went halfway there? That would mean I was at pi over 2 radians, okay? So, and then if you think about what would it mean if I was at pi, what's halfway between pi and 2 pi? That's 1.5 pi. So that would be 3/2 pi radians right here, okay? So those are major points that we're going to be dealing with on the circle. So the big key here is that you need to be grounded in the fact that right here, what we used to think of as 180 degrees, and it's still 180 degrees, that point is pi radians. 360 degrees, that point is 2 pi radians. And so if you can be grounded in those two things, we can find our way around the unit circle and be okay. Okay. So let's take a look at our unit circle and let's sort of migrate from degrees to radians. So starting out here, you're going to start out at 0 radians. Okay. If you make a revolution around the entire circle, so if you go all the way around the circle, that is going to be 2 pi radians. Now, as we said a moment ago, if I did not go all the way around and I only went halfway around, that would be pi radians. Okay. Now, let's focus on, so 90 degrees. 90 degrees is halfway to 180. So if pi is my full trip to 180, pi over 2 is going to be my 90 degrees. So that's where I find the 90-degree angle. Okay. Now let's take a look at a couple of other these. So let's look at, say, let's look at 60 degrees. Okay, so 60 degrees. So think about 60 degrees. Between 0 and 180, how many times will 60 happen? Okay, you know that 180 divided by 60 is what? 3. Okay, so I get three of those, and from 0 to pi, I'll get 3 times 60 will occur. So what I can do, I can just convert, and I can say that 60 degrees, and I know that it's 180 degrees, and pi radians. So this gives me 60 over 180. This is just pi over 3. So 60 degrees, that is pi over 3. Now, what's 60 times 2? That's 120. So that's 2 of those. So what happens if I do pi over 3 and I do pi over 3 again? So 120 is going to be 2 pi over 3. So pi over 3 2 times. Okay. Now let's just keep going with 60 all the way around the circle. So here's what I need to think of. So if I think of this as, it's pi, think of this as 3 over 3. Okay. That's the same as 1. Okay. So that's 3/3. If 60 degrees is pi over 3, then what happens when you go 60 degrees past 180? That takes you to 240, okay, which is right here, it's 240. So that's pi over 3 further. So if I'm sitting at 3 over 3 and I go 1/3 more, then that's going to take me to 4/3 pi. And then if I were sitting at 2 pi, I could think of that. That's the same as 6/3 pi. So if I come 60 degrees off of that to 300, what's 6/3 minus 1/3? That is going to be 5/3 pi. Okay? So I just went around the unit circle in increments of 3. Okay? Now let's go around the circle again. Let's take care of this 45 degrees. So 45 degrees, so if you think about 45 divided by 180, you divide each of those, so 45 will go into there, I think 5 times. So this is, 4 times. This is 1/4. So it tells me that this 45 degrees, this is pi over 4. Now let's think of this as, instead of pi, think of this as 4/4 pi. So if I go backwards, that tells me that this has to be 3/4 pi. And then if I go in this direction, right here at 225, that has to be 5/4 pi. And then I can think of 2 pi, that's the same as 8 pi over 4. So that means that this 315 degrees here, this is going to be 7/4 pi. And now finally, let's count everything by 30 degrees. 30 degrees, so what is 30 over 180? Is 1/6, okay? So that tells me this 30 degrees is pi over 6. So again, do the same thing. Let's think of this as 6 over 6 pi. Then that means this 150 is 1/6 short. So this is 5/6 pi. And then you're sitting at 6/6. If you go 1/6 more, that's going to be 7/6 pi. And then if you think about, you're sitting here at 2 pi, another way of thinking of that is 12 over 6 pi. And so 1/6 short of that is going to put us at 11/6 pi. So that puts us all the way around. The one that we left off here was what? 3/2 pi. Okay, so this looks really confusing here, but all I did was count around the unit circle, and I counted each of these angles that we've been dealing with. The quadrant angle is 0, 90, 180, 270, and then our 30, 45, and 60. So counting all of those around the unit circle. Now, what you really need to be thinking about is in your book, this is going to be an open book test. Go back to 6.1. You're going to have this right here. So everything that I just did, you're going to have displayed for you right here on the unit circle. So you can refer back to this. So that makes this an easier exercise than if we were doing all of this in class. So let's go back to where we were, Introduction to Radians, and let's march forward. So at this point, what we did in the last unit, knowing the positive values, positive, negative values for sine, that still all stays the same. But you're not having to memorize the unit circle like we would if we were doing this in class. So I'm going to skip over a few things, and let's just start evaluating. So 7/6 pi. So one thing you can think about is you always know that this is 0. This is 0. Instead of 180, we're going to call this pi. Okay, so let's call this, since I'm dealing with something that is over 6, why don't we just go ahead and call this 6/6 pi? That's the same as pi. So you can see that 7/6 pi has to be this angle right here. So it's in the third quadrant. Now if I just go back and look, so I'm looking for the sine. The sine is the y value. So when you go look at your unit circle at 7/6 pi, at 7/6 pi, what is the y value at 7/6 pi? The y value is -1/2. So the answer to this guy is just going to be -1/2. The tangent of 7/6 pi. Remember, the tangent is just y over x. So we'll go to our unit circle. What is y over x? Okay, at 7/6 pi, that's -1/2 divided by -√3/2. So that is -1/2 divided by -√3/2, which is -1/2 times 2 over √3, and that's negative. Negative times negative is positive. This just turns out to be 1 over the square root of 3. What is the sine of -7/6 pi? So think about it. If I go negative, if this is 0, over here, and I go in the negative direction, this is negative pi. So another way of thinking about this is -6/6 pi. So -7/6 pi takes me a little bit further than that on the unit circle. Okay, so that takes me to, and if you go look at it, that takes me, and I'm going to go ahead and erase what we did here earlier. So -7/6 pi takes me to this angle right here. Okay, I'm looking for the sine of that angle. So the sine of that angle is just the y coordinate. The y coordinate at that point is just simply 1/2. So if I come back, I know that the y coordinate is 1/2. Okay? Tangent of 3/4 pi. So where is the angle 3/4 pi? So if I go back to my unit circle, so 3/4 pi, I see 3/4 pi, this angle right here. Okay, if I'm looking for the tangent, remember what's our value for tangent? Our tangent is just y over x, okay? So y over x at that particular point, so y over x is going to be square root of 2 over 2 divided by negative square root of 2 over 2. So you're getting square root of 2 over 2 divided by negative square root of 2 over 2, which is negative 1. Okay. The sine of 11/6 pi. So again, just go back to your unit circle. So 11/6 pi. Where am I seeing 11/6 pi? That's right here. And I am looking for the sine of that. The sine is the y-coordinate. So the y-coordinate there is just negative 1. So my answer here is, negative 1/2. Let me double check though. Sine there was negative 1/2. Okay. If you look for the tangent of 9/4 pi, the tangent of 9/4 pi. Okay, so here I got to do a little bit of work. So if this is 0, and then I get to pi, when I come back around, that is 2 pi. Okay, since I'm dealing with fourths, another way of thinking of 2 pi, that's the same as 8/4 pi. So that means 9/4 pi is this angle you see right here. So if I'm sitting at 8/4, I need to go 1/4 further to get to 9/4 pi. So on the unit circle, so I'm looking for the tangent. So what it means here for me is that I'm looking at this value right here. That's where 9/4, that's where I'm going to find 9/4 pi, because I go all the way around, that's 8/4. One more gives me 9/4. And so what I'm looking for here in this problem, sorry about that. So in this problem, I was looking for the tangent of that value. So the tangent is y over x. That's square root of 2 over square root of 2. So that's going to be square root of 2 over 2 divided by square root of 2 over 2, which equals 1. Sine of pi over 2. So again, go back to your unit circle. And where is pi over 2? Well, pi over 2 is right here. Okay, that's the angle that's on the quadrant. I'm looking for the sine of that. The sine is the y value. The y value there is simply 1. So this answer is just 1. Tangent of pi over 3. So just go to your unit circle, pi over 3. So where do I see pi over 3? That is right here. Tangent is y over x. So that's square root of 3 over 2 divided by 1/2. So this is going to be square root of 3 over 2 divided by 1/2, which is the square root of 3 over 2 times 2 over 1, which is the square root of 3. Tangent of 3/2 pi. So go back to your unit circle. Wherein can I find 3/2 pi? That's right here. Tangent is y over x. So that's negative 1 over 0. So in this case, this is negative 1 over 0, and that is undefined, because you cannot divide by 0. So that is it. This is our introduction to radians. So what I would say, guys, is get really grounded in finding the angles. Okay, so knowing that your angles, let's just draw a circle here. Knowing that you always start at 0. This is pi. and this is 2 pi, okay? Sometimes you want to think of this as 6 over 6 pi or 4 over 4 pi. That's very helpful because if I was looking for 5/4 pi, I know that it would be right here. If I was looking for 5/6, I know that it would be right here. So when you look at this pi, depending on what the fraction is that you're looking at, it's helpful to think of that. And when you get to 2 pi, sometimes you want to think of this as 12/6 pi or 8/4 pi. It just helps you in navigating the unit circle. But then you go back to, you're going to have this unit circle for your quiz. That's going to be very helpful because you can look and read all of the values off of the unit circle.